Question 12, Part B. The points A, -2, -1, B, -2, 24, C, 22, 42, and D, 22, 17 form a parallelogram as shown. The points E, 18, 39 lies on BC. The point F is the midpoint of AD. Part 1. Show that the equation of the line through A and D is 3x minus 4y plus 2 equals 0. To find the equation of the line through AD, we need the gradient of interval AD. We also need a point on interval AD, either point A or point D, so we can use the point gradient formula to come up with the equation of the line through AD. Now, the gradient AD is found using rise over run, or change in y divided by the change in x. So using the coordinates shown, the change in y is the difference between 17 and -1, which is 18, divided by the change in x, which is the difference between 22 and -2, and that gives us 24. So gradient AD is equal to 18 divided by 24, which simplifies to 3/4. Now, point D lies on AD. We could use point A, but I've just decided to use point D because it's all positive values there, and it's generally easier to use positive values than negative values. So point D lies on AD. We have a point, we have a gradient. Using the point gradient formula, y minus y1 is equal to m times x minus x1 in brackets. We get y minus 17 is equal to 3/4 times x minus 22 in brackets. Now, multiplying both sides of the equation by the denominator 4 and expanding the right-hand side, and we can do that all in one step, we get 4y minus 68 is equal to 3x minus 66. Now, moving the terms on the right-hand side over to the left-hand side and combining like terms where we can, and in particular the -68 with the -66, which becomes +66 when we move it over, we get -3x plus 4y minus 2 equals 0. Now, it's almost in general form, but the coefficient of x has to be positive, not negative. So multiplying all terms by -1, we get 3x minus 4y plus 2 equals 0. Therefore, the equation of the line through AD is 3x minus 4y plus 2 equals 0 as required. Using the perpendicular distance formula, that is, the perpendicular distance d of a point from a line is given by d equals the absolute value of ax1 plus by1 plus c all over the square root of a squared plus b squared, show that the perpendicular distance from B to the line through A and D is 20 units. Using the perpendicular distance formula and the equation that we found in part 1, that is 3x minus 4y plus 2 equals 0, we have the perpendicular distance d is equal to the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared, where a is equal to the coefficient of x, which is 3, b is equal to the coefficient of y, which is -4, c is the constant term, which is 2, x1 is the x-coordinate of point B, which is -2, and y1 is the y-coordinate of point B, which is 24. So substituting all these values for the variables here, we get D is equal to the absolute value of 3 times -2 plus -4 times 24 plus 2 all over the square root of 3 squared plus -4 in brackets squared, which equals the absolute value of -100 over 5, which equals +20. Therefore, the perpendicular distance from point B to the line AD is 20 units as required. Part 3. Find the length of EC. Using the distance formula, d equals the square root of x2 minus x1 in brackets squared plus y2 minus y1 in brackets squared, where x1 is equal to the x-coordinate of point E, which is 18, x2 is equal to the x-coordinate of point C, which is 22, y1 is equal to the y-coordinate of point E, which is 39, and y2 is equal to the y-coordinate of point C, which is 42. Substituting these values for the corresponding variables there, we get distance d is equal to the square root of 22 minus 18 in brackets squared plus 42 minus 39 in brackets squared, which equals the square root of 4 squared plus 3 squared, which equals 5. Therefore, the length EC is 5 units. Part 4. Find the area of the trapezium EFDC. To find the area of a trapezium, we need the lengths of the two parallel sides and the perpendicular distance between them. Now in trapezium EFDC, which I've sketched here for visual reference, the two parallel sides are EC and FD. Now the length of EC is 5 units, which we found in part 3, and the perpendicular distance between the two parallel sides is 20 units, which we found in part 2, because B lies on the interval that passes through EC, and FD is a subinterval of AD. Now to find the length of FD, we first note that F is the midpoint of AD, so FD is half of AD. And to find the length of AD, we use the distance formula, so the square root of 22 minus negative 2 in brackets squared, plus 17 minus negative 1 in brackets squared, which equals 30 units. Hence, FD is equal to 30 divided by 2, which equals 15 units, which I've noted here. So the area of trapezium EFDC, using the area of a trapezium formula, half times the height times A plus B in brackets, where H is the distance between the parallel sides, and A and B represent the lengths of the parallel sides, we get half times 20 times 5 plus 15, which equals 200 square units.